So we can start this webinar. Let me welcome you on this webinar, and we would like together to present you our products, Foxtrot and iRidium mobile software, and show you their advantages and cooperation. I will start my presentation, my part of presentation with the PowerPoint. So you should see my desktop now, and we start with some schedule. I would like first to introduce you Teco company and its history. Then we will continue with the description of Foxtrot hardware, and I will show you some applications for different technologies and some typical use of modules of Foxtrot and its peripheral system. Then we will continue with a short presentation of Mosaic development tool, and we finish this first part of presentation by a practical presentation of Mosaic operation. So let's start with the company history. Teco was founded as Ltd, a company in 1993, but its history is many times older, because electrotechnical production in Kolín started in 1919 after the First World War, and it was continued until these days. First, there were produced telephone switch gears and components for telephony, but since 1966 there were established division of automation in Tesla Kolín, and in 1976 the first PLC in Eastern Bloc was developed there. Our company continues in this tradition and continues with development of our own system, which is now represented by PLCs of TC700 series and Foxtrot series. Teco consists of, or Teco Group consists of 4 companies. The Teco itself is a company which develops hardware. GeoWap is a partner that develops software solutions, industrial SCADA system, and we have two integrator companies, Proteco and Tecont, that are oriented in applications of our systems. Our assortment consists of 2 series, as I told you. Both PLCs are produced according worldwide standard IEC 61131, and we develop controllers for general purposes, for factory automation, process automation, and for building automation and home automation too. All Tecomat controllers has the origin in industry, so our controllers are robust and constructed according to industrial standards. On the picture you can see the bigger controller, modular controller TC700 series, which allows to connect several thousand of inputs and outputs. And smaller one, small brother of big TC700 is Foxtrot family, which allows in industrial automation to connect several tens or hundreds inputs and outputs, up to 300. But in building automation, it can be enlarged by wide portfolio of expansion modules, either connected to common installation bus, wire bus, or by wireless system RFox. Both Tecomat systems are integrated to Ethernet, and they are equipped with a web server that allows to users to control basically the technology with Foxtrot and to obtain information from this production or system information. We will be concentrate or focus in this training mainly on Foxtrot family, which is developed for about 8 years, and the heart of Foxtrot family is CPU that concentrates all functionality or the most of functionality of all system. Foxtrot itself or Foxtrot CPU itself can be enlarged by wide amount of peripheral modules, either connected via system bus by quick system modules, or by installation modules that are connected to CIB, common installation bus, which is not so quick as industrial bus TCL2, but it allows to connect modules with any topology without necessity to connect modules in the line. It can be connected to star or to tree configuration and so on. This peripheral system is closed. It means nobody can't add modules to this assortment, only Teco, only we. But on the opposite side, you can see that Foxtrot systems can be connected to Ethernet or to Internet and can be connected with many modules of different producers. And the communication protocol of Foxtrot in the upper level is fully opened, so anybody can use either our communication servers, OPC servers, or can create his own drivers, communication drivers. Then Foxtrot can be connected to any interface, to any device, starting with smartphones, and it can be represented by many various devices. Here you can see the orientation to industry processes and to building automation processes. For both are used the same systems, the same family, Foxtrot. Foxtrot consists of 10 types of central modules. Each central module is equipped with Ethernet connector, which allows to connect Foxtrot to 10 megabits or 100 megabits Ethernet network. Each controller is equipped with the web server and with the SD or SDHC card that can work as a mass storage for data storage, or for web server which uses its file system. The number of connections realized by Ethernet can be enlarged about other communications that are established through up to 10 serial lines. Serial lines can be connected either directly to CPU, which is equipped with these replaceable submodules of communication interfaces, or other communication interfaces can be added by DIN rail modules. And of course, each Tecomat is equipped with the interface for both system buses, Quick System Bus TCL2 and Installation Bus CIB. The first representant of Foxtrot family is CP1000, which has some clone with enhanced memory, which is named CP1001. This CPU is equipped with two CIB buses, and it is especially designed for building automation. For industrial automation, it is developed CP1003, which has enhanced amount of connectable TCL2 modules. So it can realize quite big applications with 300 inputs and outputs connected to one Foxtrot. If you need more inputs or outputs to connect to one CPU, it is necessary to use TC700 family modules. And then there exist other modules, other CPUs with different configuration of inputs and outputs that can be used for any purpose, for any application. CPUs started from CP1004 and 5 are designed as a classical PLC with 24 volts inputs. CP1006 and 8 are used mainly for measuring and control for regulation purposes. Each Foxtrot can be enlarged by 10 peripheral modules, I/O modules that are connected by TCL2 bus. The data from these modules are refreshed in period of 5 milliseconds, about 5 milliseconds, and therefore the length of line, which is based on RS485, cannot be longer than 300 or 400 meters, so that we can reach this refresh time. TCL2 bus has only line topology, so it can't be divided to more branches. The only exception is if you use fiber optic converters that can convert metallic wiring to optical fiber, and that allows to divide the line to two branches. Besides I/O modules and converters, you can connect other 4 system communication modules and 6 optional communication modules with RS232 or 485 interfaces. And some operator panels can be connected to the assembly too. You can see that these panels are used mainly for, or designed mainly for, industrial applications. For building automation, you can connect panels which are equipped with Ethernet and has touch screen for user control. Here you can see the assortment of CFOX or RFOX peripheral modules. These modules are divided to several groups. Either there are DIN rail mounted modules for cabinets or wall mounted modules for interiors. And these modules, this smaller one, can be placed in installation boxes under flush or in some tubes or pipes for measuring, for example, temperature. So even these modules can be used in industrial applications, only the speed of communication is not so high. Here you can see again the portfolio of CIB modules. These modules can be connected in amount of 32 pieces per one communication master, and each CPU is equipped at least one communication master for CIB bus. The length of bus is about 300 or 400 meters again, but now this is limited by power drop, which is caused by length of cables, because this CIB bus ensures powering or supplying of all installation modules. So all these modules can be connected only by two wires, which makes easy the installation in buildings, because you can create different branches, you can design optimal topology of the network, and the bus ensures, besides the communication, supplying of all modules too. Only these bigger modules on for DIN rail installations are powered from power supply in cabinets. If you need to enlarge the amount of CIB modules, you can connect up to 4 communication masters, external communication masters, to each CIB, which allows to enlarge the amount of connectable peripheries, switches, temperature sensors, different displays, so on, up to several hundreds or even thousands of inputs and outputs. But usually this amount is not used because in bigger applications it is better to divide the control between two CPUs. But one CPU allows to connect, in fact, a huge amount of inputs and outputs itself. The other peripheral system is RFOX, which is working on frequency band 868 MHz and doesn't require any license. So you can install it anywhere without necessity to some papers, certificates, and so on. Again, you can connect up to 64 modules, RFOX modules, to one communication master. It is similar to CIB communication masters, and it allows to connect up to 256 modules to each CPU. The communication is bidirectional. It means all information is confirmed by the device which is receiving the packet, the information. Then the data has not be transmitted twice or 3 times, or you don't need to repeat the operation if the packet is not delivered for the first time. The device itself repeats the transmitting again. So that you can connect slaves to RFOX communication master, to their dedicated master, you can start first so-called bonding process. It means you can create a couple, a pair between master and slave module. Then it is not possible, so that some module influence modules in the other installation, for example, in the house of your neighbor. After successful bonding process, you can place all modules to their places and to their locations, and you can reach the higher distance from master by using of routers or repeaters that can be placed in some important points of applications and can retranslate the signal from modules that are in higher distance from communication master that can't be overtaken by one hop, so-called hop in communication. It allows to place modules in the distance from, let's say, 50 up to 80 meters from CPU. The normal distance for direct connection is according to material of the building, and it is about 20 meters from communication master. I told that Foxtrot is open system for integration of other processes and other systems. So it means you can connect a lot of devices, a lot of products of other producers. You can see, for example, iRidium here, and it is ensured by AppsNet communication protocol, which is open for all users, and they can integrate their devices with Foxtrot, or we can integrate Foxtrot with other devices. Further, Foxtrot supports a lot of standard protocols, as for example Modbus, MBus, BACnet, that allows to connect other devices that are that use these standard protocols. One of these protocols is KNX. So we can integrate, even if we have our installation bus and our peripheries, we can integrate Foxtrot with KNX systems, and we can offer to our customers wide spectrum, wide portfolio of different modules that can be connected with Foxtrot using KNX IP server that converts communication from KNX network to Foxtrot system. This communication is supported by function blocks in Foxtrot's program. And besides these KNX or different modules, remote controllers, we can use different touch panels, either dedicated touch panels or general purpose tablets based on iPad or iOS operating system, Android operating system, and so on. So the user has a lot of possibilities how to visualize, how to control his system. So applications of Foxtrot start with the light control, which is supported by wide portfolio of products for switching and dimming of lights. You can see here that they are supported all types of lights that are used in up-to-date installations, some modern LED lights, and so on. We support two lights that are communicating via communication standards, as for example DALI or DMX. For these communications, there is support in Mosaic in libraries, and the example of such interface of such library you can see here on this picture. If you want to control the house or the technology in your house, you can you can choose different designs of different producers that can be connected to standard CIB network with these bus couplers, with these small modules, which are placed behind the switch or behind the controller in installation box in the wall. The same or similar situation is for shutter control. Here we can directly control AC or DC motors for different jalousies, rollers, marquises, simply for shading devices. Again, you can find a lot of information in our manuals and documents that are concerning this. What concerns security systems, there are two approaches that are supported by Foxtrot. Either you can use communication through serial port or Ethernet port, and you can connect security systems or fire alarm systems of different producers. You can see some of them that are supported by libraries directly in Mosaic. Or you can connect individual detectors directly to inputs and outputs of Foxtrot system. Usually modules that are used for connection of detectors allows to supply these detectors from 12 volts power source. And here it is an example of connection of DSC security systems, certified systems via RF232 to Foxtrot. Access control, it is another category of applications where Foxtrot is used. Usually we offer the connection of RFID card readers or keyboards via VGAN protocol, which is again the standard in building automation. So we have not keyboards in our assortment directly. You can choose any design from any producer and connect with standard interface, standard module to CIB bus. The example of connection with the CIB module is presented here in this picture. Heating control or temperature control is realized with different room controllers with different designs. Of course, you can choose the design according to design of wall switches and other devices. And the information from these thermostats, from these modules, is ensured by CPU. And CPU, through their outputs, realize the control, either three-state control or continuous control of valve position. So analog or three-state control is supported, is allowed. Here you can see that the portfolio of our temperature sensors is or contains outdoor modules, modules for air pipelines, for sleeves, for boiler temperature measurement, and so on. Here you can see the actuators, valve heads, or switching or control modules that can be connected, for example, with fan coil controllers or for HVAC units, and the structure of control is here. Foxtrot with some devices in upper level for visualization and control, peripheral modules that are connected directly with outputs, heating cables, ventilators, valve heads, and so on. And for measuring and control via physical modules, you can choose from a lot of designs and a lot of types of modules. Here is again the example of communication. The next chapters that can be presented is measuring of electricity or consumption of electrical energy, gas or water or heat that are connected to the system, or by counters or by communication lines. For as an example of a device which is connected to system via communication line, we can use this analyzer, which allows to measure parameters of electrical network. And of course, it is possible to connect a lot of sensors that measure non-electrical values, as for example humidity and so on. Here you can see the example of interconnection of KNX and PLC Teco Mat Foxtrot world, which is realized by this BAOS KNX IP server, and we can use the bigger advantages or the biggest advantages of both systems. And then the designs from KNX are available in Foxtrot. The last part of presentation, it is dedicated to Mosaic. Mosaic, you can download this software with our pages, and if you will use it without USB dongle or license directly in Foxtrot, it can work as a limited Mosaic Lite version, which is equipped with the simulator and allows you to show some features and functions of Mosaic system without necessity to buy real hardware and to buy the integrator license for this software. And if you need to start your own applications, to build your own applications, then you can buy the license. This license can be either loaded to CPU, and when you connect Mosaic to this CPU, then the software is opened, or you can use the dongle, which opens Mosaic on computer on which is placed in USB port. Mosaic has a lot of different tools. I will show some of them in this presentation, and allows to use 5 programming languages for creating the applications. Here you can see a graphical language in traditional LD, ladder diagram language. This is a function block diagram directly according to the standard IEC 611313, and the last of presented languages according to standard is textual language structured text. In the last years, the programming languages in Mosaic was enlarged by CFC language, continuous function chart, which is not defined exactly in the standard, but it has the same features as FBD language, but it is more comfortable for users. And we will see this language in a real example. As a part of Mosaic, you can find WebMaker, editor of web pages for Foxtrot, that allows you to create your own interface, which is connected directly with variables in the system. And other tools like GraphMaker that allows to record the values during the time, which can be used for analysis of the system, and other tools for creating of application programs for panels, and so on and so on. Here you can see tool for PID control, supporting PID control design, and so on. The Mosaic is equipped with context help, and all technical documentation is part of Mosaic directly, so you can open any manual directly from Mosaic software. The user program can be equipped with the password to have full access for programmers, and to make some limitations for normal users. You can recognize up to 10 levels of password in one application program. As I told, each PLC can be equipped with SD or SDHC card, which is used mainly by data logger software that allows to measure and to collect the data directly on SD card. Then the PLC is independent on different SCADA applications, and it can work as independent unit that can send the data collected by data logger, for example by email, or you can download these files through Foxtrot web pages or other application which is connected with Foxtrot. Here it's mentioned the service tool firmware updater that allows not only locally but remotely to make updates of system firmware, which is in fact operating system of PLC. So not only programming tools but service tools are available for remote access to the system. So you can operate with Foxtrot remotely from your office room if this Foxtrot is connected to Ethernet. And there is mentioned the possibility to connect Foxtrot with other devices through AppsNet drivers, or you can use directly PLC communication server, which is developed by Teco company, and it is designed for people that have not the possibility to develop their own drivers and want to use some ready-made application software or interface as a gate to Foxtrot system. And the last information, we can offer so-called application profiles that enables licensing of programs, and that allows you or give you as a programmers possibility to write your specific functions that can be covered by this application program, and nobody then can't see this the content of this your function blocks. So this is the part of Foxtrot presentation, And now we can see a short presentation of Mosaic in live connection with iRidium software. I have prepared a small application program in Mosaic, which consists of two function blocks. Both these function blocks are from a library, which is part of Mosaic, and you can use these library function blocks in your applications. You have possibility to write your own function blocks, which is represented here by very simple function block written in textual ST language. And this function block allows to select the color that can be then set on the output of system. It means on a dimmer unit. The program is created from blocks that are placed to the workplace. If you put the blocks to the desktop, then open editor window that allows you to define the features or the behavior of the function block. Defined function blocks you can connect very simply with the variables in the user program. So you can draw this connection with input element, and you can select from some list of variables the variable or input of the system which is connected with the proper input of function block. Then you can load the program, compile the program here, and load it to the CPU. And if the program is in debugging mode, now I have switched it to debugging mode, you can select the color, and you can set the color on the output of the system. You can see that if I change the color, the status of proper output is changed in Mosaic Debugger 2. If you want to export these variables for other systems, you can use so-called public file, which can be generated by programmer directly in Mosaic. And this file contains the name or address and type of shared variable. Then you can open the development tool, in our case iRidium Mobile, and you can define in the application connection directly to some variable in Foxtrot. There is the register and address of variable in Foxtrot. You will see it in the next part of presentation. Now we can try to select some color. So now I have switched on all parts of RGB strip. So there is displayed blue color on LED lamp, and the same you can see in Mosaic. If I change the color to yellow, again you receive this information on panel with the iRidium control software, and you can operate with the device from both channels, from both places that are prepared in the application. So that's all from my part of presentation. Thank you for your interest, and I give the microphone to Ekaterina now.
Thank you, Lubos. It was very interesting. And let's start the next part of our webinar. It's about iRidium mobile software. You have saw the little part of our editor here. with RGB control, but let's start from the beginning. Now I'll show you my desktop. Do you see it? You have to see my desktop with the blue screen.
Not yet.
Not yet?
Not yet.
Waiting for video. Just tell me when you see the desktop. I'm not sure that it works fine.
Now
What do
we
you
can
see
see
now?
it. Now we can see. Yeah.
Blue screen or my browser?
Yeah, blue screen.
Okay, great. Okay, so iRidium for Teca PLCs or TecaMat controllers. What is iRidium and what is iRidium for? iRidium is a software package which allows you to create a graphic interface to control any automation system and any equipment supported by iRidium. Teca is in the list of supported equipment, so you can control your Foxtrot PLC by EPSnet protocol. It works using UDP. You can connect to PLC multiple control panels like iPads, iPhones, Android tablets and smartphones, PC or Mac. You can create any graphical interface for your control panel. It's a very important thing when you making high-end project, automation project, and when you have to make a great visualization. iRidium allows you to make this visualization and control it with the GUI, which you create in yourself and which you can make to work as you wish. Let's start from the communication scheme between you, the man who develops the graphic interface and program for PLC, and user. User is the man who uses your graphical interface and who live in the smart home, for example. All the iRidium components for developer are situated on your PC, Windows-based PC. It have to be Windows 7, 8 or 8.1. On the PC you have to create a user interface. In the graphical editor it calls iRidium GUI editor. You have to make the data processing rules. It means that you have to create the list of addresses, registers you want to control on the Teca side, on the controller. You can control some addresses on PLC and you can get some data from PLC. All these addresses have to be created in your GUI project. When the project is done, you need to get the license. iRidium doesn't work with equipment without license, but you can start some graphical interface without any license and, for example, show to your customer how it can look like. But when you make the GUI and get the license, you can create some difficult scenarios and logic using JavaScript in iRidium. It's a standard JavaScript with special methods, functions, and events inside of GUI editor. In the bottom of the scheme, you can see which parts of your interface can be controlled with JavaScript. It is user interface. It is driver, so it means you can send the command and process the received data from PLC with JavaScript. You can control system variables of your smartphone or tablet, like time, date, and other variables to make something by the system events. You can control the sound. For example, you can play sound when something happens on the PLC side. You can make the complicated animation inside of iRidium. It is great when you need to animate your project. It is not easy to make the good animation in web interface, so you can use iRidium to make animated GUI. And you can also create your own drivers inside of iRidium using JavaScript. It means you can create TCP, UDP, HTTP, JSON drivers to control any additional equipment which is not supported directly by your PLC. iRidium can work not only with the PLC, it can work simultaneous with some controllers, audio-video equipment, and external servers. When the developer made a GUI and made a program for PLC, he's uploading ready user interface to the control panel. Control panel is a tablet or smartphone or your PC. It's an application on your smartphone. You cannot start your GUI in browser like a web interface. It is application-based visualization. So you can start it only inside of our application. It calls i2Control v2.2. And you can install it from App Store, from Google Play, or from our website if you want to start it on Windows or Mac. This application starts the graphic, plays the sound, processing data, and interpretate the JavaScript. All the needed processes are inside of application. We don't need some external server or PLC for your interface. The end user see only the graphic interface inside of our application. He can start some scenarios, turn on light, see the status of the variables in the real time. It works very fast and you can create a great visualization. Any additional functions you can use in iRidium? First of all, it's a SAP intercom. It's a free function you can implement in your GUI. It allows you to call to door phones like 2N, Mobotics, Bus IP, or other door phones with SAP support. Or you can communicate between iRidium panels using voice. It is for free and we have already interfaces to work with SAP. You can see more about it on our website. iRidium supports DVRs, IP cameras, and intercom panels. It means that you can control your PLC and see the video from the IP cameras in the same app. It is very important for the security part of your project. iRidium allows you to upload not only one project, but the 2, 3, 4 or more projects, graphical interfaces on the same control panel. It can be used if you want to control several objects, several automation objects from one device. For developers, we have features which makes your life better when you need to create interface faster. Interface Wizard allows you to choose some pages and GUI themes inside of editor and use them in your own project. You can also use pre-configured themes in GUI editor to create buttons, levels, edit boxes, and other items in the iOS, Metro, or Android style. On our website, you can see the big list of pre-configured templates. Template is a GUI, it's a user interface, which you can use if you want to make the GUI in the style which you have seen on our website. You can create the GUI from zero with your own design, but it is easy to start with a free template, free interface from our website. We have also the ready JavaScript modules. JavaScript modules means that you have interface and driver which allows you to control some pre-configured systems like Sonos, iTunes, XBMC. They allow you to get the weather from Yahoo website or something like that. You can just get the free JavaScript module from our website, add in your own interface, and just use it. It is ready. About licensing, we have only one type of license for EPSnet protocol. It calls device license, and it allows you to control any Teco PLC from one control panel. So you cannot use the license on another control panels, for example, iPad or iPhone. It will work only on one of them, but you will be able to add in your GUI Teco PLC and audio-video equipment. You can see the price for iRidium on our website after the full registration. The price for integrators of automation systems will be available for you only after the full registration as a company which working in the automation area. Okay, let's start with the practice. I have get the pub file from Lubosh, and I just opening it in the Notepad++. I see here the addresses which can be controlled using EPSnet protocol, which can be controlled in iRidium. I need not all of these addresses. I want to control RGB, dimmer, and I want to turn the light on and off. So I need these three channels, red, green, blue, to control the RGB. I need this channel, it calls dimmer level, and I can control it from 0 to 100. And we have channel light on off, which allows you to turn light on or off. How to use this table? It is not simple when you see it first time, but the structure is pretty simple. Let's start with a new project in iRidium GUI editor on my PC. When you create the new project, let's start again with a new project. You need to choose the resolution of your project. When you choose the resolution for iPad 1 or 2, for example, it does not mean that you will not be able to control, to upload this interface on Android or Windows. You will be able to use them to any operation system. But if you want to start the interface for tablet on the smartphone, it will be pretty small and it will not be convenient to use such interface. So if you need interface for tablet, you have to choose the resolution of tablet. If you need an interface for smartphone, please choose the resolution of smartphone. If you cannot find the resolution of your own smartphone, tablet or PC in this list, please choose custom and add the resolution manually in this field. But I'll start from the interface for iPad. The first page of my interface will be landscape. It means the tablet will be horizontal in my hands when you want to control the interface. When the project created, you see the project properties. We'll back to this page later. And in the project overview, you can see the first page of your project. This page is gray. Here is no control items and no information here. So let's start with the GUI wizard. GUI wizard helps you to create the interface faster. It will be interface in some pre-configured style. I choose in metro style. And let's see the pages which we want to see in our GUI. First of all, we need a main page of project, navigation page. And we need some page to control lighting. For example, this page, lights and shaders. This page can be changed as you wish. You can add or delete some control items which you don't want to see in your interface. We will delete the first gray page which has been made by default because we have a main page. In the project properties, we can choose which page of our project will be shown by default. In Setup menu, choose the first page of your project and choose the pop-ups which you want to start by the application start. Okay, we have a navigation project. We have a pop-up to control the lighting. We can make a clone of this pop-up to add more functions here. And now we need to make a EPSnet driver here. Unfortunately, we cannot just import the data from pub file in iRidium. We just can use it like a table with the addresses, type of registers, and the main data which we can use. But you have to go to device base, find an EPSnet driver, and add it manually in your project device panel. Project device panel is a window which include all the drivers which already added in your GUI and which you can use here. First of all, we have to set up the IP address of our Tecomat PLC. In my situation, it is 0 to 115 address. The port of UDP communication is always the same. Don't change it. And update time is the period of status requests. For example, it could be 500 milliseconds. In the comments and feedbacks list, you have to add the list of registers you want to control. It's a comments. And you want to read. It's a feedbacks. If you want to control and read the register at the same time, you have to add it in the comments and in the feedbacks. Driver tokens tab includes the system tokens. It is a status of connection to your PLC. It is very important to see if you are connected to PLC or not. For example, with a tool for creating of items, we can make the new item and put in the first state of this item offline word. In the second field of this item, it will be green. We can add online. So this item includes two states. First state is offline, second state is online. Drag the online token to this item in value. And now when you start your interface, it shows you is the connection has been established or not. For example, if I'll add an incorrect IP address of EPSnet controller, I won't be able to connect to it, so the item will be in the first state offline. I can check if it works or not only if I have a license. You have to add the license for emulator in the Tools Options field. Turn off the demo mode and put here the path to the license. It could be trial license you can get from our website for free. I'll show you how to do it for the first time. Sorry. We are going to English iRidium mobile website, My Account section. Now you have to log in. And then go to the Trial tab. In this tab, you can press the button Get Trial. 2 trial licenses will be added in your cabinet, My Licenses section. How to get the trial license for your own PC? You need to use iRidium Transfer application to do it. Open the iRidium Transfer. Here it is. After the first start, you will see the transfer app with only one screen in the first tab. It will be your own PC. You need the hardware identifier of your PC to make the trial license for your PC. Press the right click, press copy HWID of your PC. Go to My Licenses section and activate the trial license. Press button Activate. Add here your HWID. OK. Download the license file to your PC in IRL format and add it in iRidium Transfer app. You can do it by drag and drop function. Once the license added, in Transfer, you can add it to Editor. Tools, Options, License Path. When it is done, you can check the connection with the PLC. As you remember, we made a button which shows if we are connected to PLC or not. Let's start the emulator and see how it looks like. When the address of PLC set incorrect, the status of connection is offline. When the address of PLC are correct, you see online status. And now we are ready to create the communication registers to control RGB, dimming, and lighting on the Teco side. Let's see on the pub file again. And we start from the simple lighting control. This address, light on off. I copy the name of this register. So GUI editor. You can put any name of this register here. The next word in this string is a register type. It's a user register. You have to add the same word in a register type field. The size of register could be Boolean, real, string, or other type. You can check the size of this register in the Foxtrot documentation. Boolean means Boolean number. It is 1 bit. Real means 32 bits, unsigned. Oh no, it's a float 32 bits. So we do not have special words, keywords in iRidium, so you have to choose the size of register in bits and data types. Just compare it with the documentation table. Okay, now we know that Boolean means 1 bit. And just choose Boolean and the type of register in GUI editor. Now the address of register. Here it is. It is 418. And now the bit of register you want to control. It's a 3rd bit of register after the dot. Put this number in the last field, calls bit. And now you can control this register with this command. But I want to get the status of this register also. So by the right click, choose Create Feedback command, and iRidium automatically makes the feedback channel for your command. So you can write and read the status of light. Let's make a button to control this light. I want to turn it on and off with help of 2 buttons, for example. So I'll make 2 buttons for lighting control. This button to turn light off, and this button to turn light on. We can choose any icon for these items and put them here. You can also choose any color and size of these items. For example, let's make this button red. It will turn light off, and this button orange to turn it on. When it's done, we have to drag the command from project device tree to our item. And before we made it, we have to choose the correct type of these items. If you want to control the light from the separated buttons to turn it off and on, you have to choose the simple button with the feedback momentary and drag the register on these buttons. When you drag it, you see the window which allows you to choose which event of user interface will turn the light on, and which event turn it off. It could be press, release, hold, or move event. Now it's done. And as a last step, we can display the current light value on this item. $V template allows you to show the current value of variable in the text field of item with some additional symbols like a %. Just drag a feedback of light status to this item and choose in value. Now we are able to start our project and see what happens. When I press off and on buttons, the status of register changes, as you see on display. % is not correct for this time. And we can make it back. Gray. If you want to turn the lamp on and off from the one button, you have to create trigger button. Trigger button allows you to change the register status between two values, trigger value 1 and trigger value 2, 0 and 1. The trigger item have to be made of two states with the same icon but with a different meaning. When the trigger button is in the second state, it means that the register turned on. That is how it looks like. We have to drag the command to this button again, but do it by the different way. When you're working with the trigger button, you have to use the press event, and you have to use the feedback channel from the controlled register. Trigger button will not show you the real status of controlled equipment if you don't use a feedback channel. When the button configured, you can see the command on press event, and you can see the feedback channel in Relations tab. If you see it, it is done and our button will work properly. When the project started, you see our register is in the active state. It's turned on. When I press the trigger button, it turns off. And so on when I click on this button. When we are working with a simple Boolean register, it could be just 0 or 1. So we have to use buttons or trigger buttons. So we have no choice. But if you want to control the dimmer, it could be controlled in the area from 0 to 100. Our dimmer register calls dimmer level. Let's make it in iRidium. Dimmer level channel. The address of this channel is 481. The type of this channel is unsigned 8-bit. It's real. The real in this table, oh sorry.
It's float.
Something
It's
wrong.
float.
Dimmer
It is
level.
float.
I think it's correct. Unsigned 8-bit from diapason from 0 to 100. We create a feedback channel, and now we are able to control this variable from the level item simple button, trigger button, and up-down buttons. What does it mean? You can control the dimmer item from the different type of controls. First of all, the level, the simplest way to control the dimmer, looks like this item. It can be bigger or smaller than you see in the default user interface. You can set it up as you wish, but the diapason of this item will be the same anyway, from 0 to 100, as you set up in the level properties. We can also make a display to indicate the current state of our level with a %. We can make a plus and minus buttons to increment and to make the level bigger or smaller, step by step. Up-down button is a little complicated in setting up when you set it up, but I'll show you how to do it. We have Alt trigger button to turn it on and off, and we can create a simple button to set our level to some value, for example 50%. Okay, let's start from the level. We have to choose the minimum and maximum of the level item, and when it is done, we have to drag the command light dimmer level to this item. With the level item, we can use press, release, and move event to send the data to controller, to PLC. What it means when we use press, release, and move events. When you press to the level item first time, iRidium sends the value to PLC. When you drag your finger by the level item, iRidium sends the levels step by step to the bus, so you can increase or decrease the level item continuously. But the move event works very fast. It sends the data to the bus very often, so we have to make the delay between the command, for example 100 milliseconds, to make the data not so aggressive. And the last value of level will be sent when you release the finger from the level item. Of course, you can use the level without move event, or you can use only release event, for example. But you can also use all the three events at the same time. When you need to set up down button, you have to implement increase and decrease values for your level item. When you want to decrease the level item step by step to -1, you have to edit this value in up-down value. Min-max value means that the value should not go lower than 0. When we speak about increase item, you have to add the +1 value and the maximum of the level item. It is 100. And then you just drag the command to control level item to these buttons. With up-down button, you have to use press event, and you should also use the feedback channel with this item. It will not work without feedback channel at all. with the second button too. Why the up-down button doesn't work without feedback channel? It looks at the current state of your level and makes the -1 math operation and sends the result to the bus. So if the button cannot see the current state of the variable, it sends 0. It is not correct. Trigger button works the same as with a bit value boolean, but you have to change the current value of dimmer between 0 and, for example, 70, or you can choose 100, any level as you wish. Drag the register to this trigger item and use the press event with a feedback channel. With a simple button, which should set the 50% of level, we have to set the level in the command field when you add this command to level item or to the button. You don't need a feedback channel in this situation. This button just sends a 50. That's all. Let's see how it looks like when we connect it to the PLC. All these buttons works at the same time. You can turn it on and off with the trigger button. You can increase and decrease it with the up-down buttons, and you control it with the level. I did not made a feedback for this template, so we will do it now in value. This button do nothing. Start it again. And now you see that the level changes in the display item. We can set up the constant value from the simple button. We can make it bigger or lower with separated buttons, and we can turn it on and off. It is simple and fast. And now we have to set up RGB palette in iRidium. As you see in example from Lubos, it is simple to make the RGB palette in iRidium to control the separated channels R, G, and B. Here is ready example of controlling our RGB palette. We can use it in our ready-made project, but I can show you it in the separated project. It is simple to turn RGB channels on, off, or it is simple to control it with a level item, but it is much greater to have a RGB palette in your interface and just choose the color with one click. Your RGB panel can be made on any image. You can find any image in internet which include the colors you want to set on RGB, and you can add it in GUI editor and use as a palette for your RGB. How to use it? Open the script editor with the pre-configured RGB library. You don't need to change these scripts. You just need to set up the properties of your own RGB palette in your own GUI. Here you can see the ready-made RGB panel, and if you have any other page with a palette, you can add one more RGB item. Just copy and paste the previous one RGB in your project. What you have to set up in the properties of this script. Please see the comments in the script and do the same. First of all, you have to set up EPSnet UDP, the name of driver in the project device panel. In my panel, in my GUI, it calls EPSnet UDP, but you can call your driver Teco, for example. So you have to add this name in the first string of the script to control RGB palette. The next three strings is the names of RGB channels in your project. Red, green, blue channel. It's unsigned 8-bit registers. Here's the addresses. We have to add these names in the properties of our script, so the script know which channels have to be controlled with the palette. But then as a next step, you have to add the links to the items on the project page, which works as a palette and as a display, which shows you the current color of RGB. My display is this item. It calls item display color 1. My palette is this item color picker 1. I will add these names in the next strings of this script. First of all, add the name of page where the palette situated. It is DMX page. And then add the name of item to control it. You can also add the buttons up and down. It works like increase-decrease up-down buttons. In the previous example, these buttons. But it cannot be used without the script. If you don't need these buttons, just ignore this part of script. Comment it, and the last script we don't need to use too. But you can just create these buttons and control the RGB brightness with them. It could be convenient. But for now it is done. We have made our first RGB palette on the first page of our GUI. Check the license was added in our project and check the IP address of your controller. Now we are able to start GUI and control our RGB. As you see, it works properly. You can see the current values in the red, green and blue channels. White, red, green, yellow and other colors. I can change these colors with the plus and minus buttons. It works properly with the controller, with the real PLC, with the real RGB. If you want to add the pre-configured RGB in your own project, you can just merge RGB project and your own project by drag and drop in GUI editor. I just get the EPSnet RGB player sample and drag it to project 1. Project 1 is the new project we have made from zero. We have to save the project. And now, as you see, we have a GUI included our RGB palette. But in the project device panel, you can see now two separated drivers. You can drag the commands between the drivers of one type using drag and drop. When it is done, I can delete Teco driver, change the script to work through EPSnet UDP driver, and set up the main page, DMX page. As a result, you can see our RGB palette and our lighting control pop-up. You can disable this pop-up in the project properties. When it's done, you can then send the ready project to control panel. Control panel, your tablet or smartphone, have to be connected to the same Wi-Fi network that your PC. You have to send it to transfer. Press send to transfer button to upload your GUI to some control panel. If your control panel is not in list yet, you have to search for control panel. The searching process works when iRidium started on your control panel. You have to install the app i2control v2.2 to your smartphone or tablet, and you have to press the search button in transfer. Now I see all the control panels where iRidium started now. I need only my iPhone. I don't need other panels. And I can choose the license for my iPhone. If you don't have a license yet, you can get the trial license for the testing device. But I can download it without license at all. And now, choose the project you want to upload to the control panel. It calls project 1, and press upload button to start the uploading process. You can see the uploading process in the taskbar and in the transfer log. If you have any problems with uploading, please see the article on our wiki pages. It's iRidium documentation. Go to iRidium transfer section and open solving problems with project upload and panel search. Here you will see all the possible problems which can happen with your network, with your antivirus software, something like that. So we will be able to upload any GUI to your tablet or smartphone. When the project uploaded to your device, I hope you can see it, you can turn the update process off, turn transfer off, and your project will work without any connection to server or PC or other devices. You need only your device and Wi-Fi network to control Tecomat PLC. You can also save the GUI in the protected format to be sure that your unique interface will not be stolen, for example, by another guys from automation companies if they see it on the device of your customer, Android device or Windows. Okay, I hope it is clear about everything about register types in the pub file. And if you have any questions, I am ready to answer.
there were a question concerning.
After end of the webinar, we will make a delivery with the.
There were a question concerning fixation of registers on the Foxtrot side, so that possible changes of program doesn't influence or doesn't affect the visualization in iRidium. So I can connect my screen again.
Okay, I'll turn off my demonstration. Ready?
It is still connecting. Yes?
Lubos?
It is still connecting. Please wait. Yes? It is still connecting. Please wait.
After the end of the webinar, you will be able to see the record, and we will make a delivery with the projects and presentations you saw here. So you will be able to repeat my actions, and you will be able to upload the sample project for Teco PLC. Question about licensing. If you have more than one iPhone, you have to buy the multiple licenses. One license for one iPhone. You can buy the license only if you're registered, and you have to go to the Buy section. Here it is. Here you have to choose iRidium for EPSnet, and I cannot show now the price. It is an open video, and our dealer prices are closed for the public. But if you have the multiple panels, you have multiple licenses. One license for one control panel. You will be able to buy the keys, add it to My Licenses section, and activate them for control panels by the HVIDs of these panels. For example, to get the license for my iPhone, I have to copy the HWID of my iPhone, go to the My Licenses section, and activate the license for HWID of my iPhone. So now I am able to control Tecomod and other equipment from this iPhone. It is the same for other devices.
So can you see my screen now? So can you see
Yes,
the
yes.
question how to fix register in Mosaic project. In this project you could see that the variable that contains the settings for RGB was defined here, and we can double click here on this list, and sorry, when we are in editing mode. So I switched to editing mode now, and when I double click the name of variable, we can set here absolute position. So we can say that this variable will be in some register, and Mosaic, when compiling the project, will not move this variable even if the changes in the program would be done. So if I write here, for example, R0, it will fix this variable in register 0. So we have defined this set RGB first from register 0, and now when I will make changes in the program, it will be still fixed. If if you want to fix the variables that are that concerns all this function block, you can define this function block not locally, as I did it here in the main program. I have defined this block as local, but we can change it. We can move it to var global section, and again, if it is declared as a global variable, we can again put it on some absolute position in the memory. If I would like to know where this function block is placed, we can see it. It's not seen. It's not seen because there is the space for all objects defined in the main program generally, so we can't see it. But if I fix this variable as a global variable, it will be defined for next time. So now I will do the changes in the program, but for the next time it will be fixed. So if I put it to register 1000, and I didn't check the public. So now all content of variables that are part of this dimmer function block will be fixed in the program. By this movement from local to global variables, I changed the position in the program, but for next time it will be fixed on these addresses. So if you want, you can fix the variable in the memory so that changes in the program doesn't affect the visualization application. So are there any questions?
If you have any other questions, you can contact us via email or in Skype. Here is our support email. It's my Skype.